Hi everyone, my name is Jérôme Fink, and I'm going to present our work adapting queries to database schema changes in a hybrid Polystore. First thing first, what is a hybrid Polystore? It is a database made of several database technology. Here you have an example of an e-commerce system using a Polystore. It means that it persists its operational data in 4 different databases such as MongoDB, Redis, etc. The main issue with this kind of architecture is that often we don't have a unified schema telling us where the data are actually stored. Another issue is the number of query language used in such an architecture. So for instance, if we want to adapt a query from a relational database to a query applied to a document database, we need to change the whole syntax of the query, which is difficult. To solve this problem, the European Union launched the Typhon project, which aims to provide process and tools helping developers to build and maintain their hybrid Polystore. In this work, we will focus only on 2 modules of the Typhon project. The first one is the TyphonML Polystore schema. The TyphonML Polystore schema describes the architecture of the Polystore. So you have 3 parts. The first one is the conceptual section, which describes all the entities that will be persisted in the Polystore. The physical mapping will map those entities into an actual database. And the schema modification operator lists all the pending modification applied to apply to the schema. The second module is the Typhon Polystore query language, which is expressed upon the conceptual part of the TyphonML schema. It's one single language that allows us to query the whole Polystore. The QL engines resolve the physical location of the data by itself. With these 2 modules, we have a unified schema for the hybrid Polystore, a finite set of change operators able to represent all the change possible on the TyphonML schema, and a single query language for the whole Polystore. Thus, our query adaptation problem becomes how to adapt TyphonQL queries to an evolving TyphonML Polystore schema. Let's dig into that. In order to adapt query, we need 3 things. First, the input query to be adapted. Secondly, a source TyphonML schema on which those queries are expressed, and the schema modification operator to apply to the TyphonML schema. The result of our process is a list of modified queries which work on the target TyphonML schema. Let's imagine that you're a developer and you want to upgrade your query after a modification in the TyphonML schema. First, you will have to reference the correct version of the schema on which your query are expressed and containing the correct change operators to apply. Then you will list all the query you want to update in the query evolution script. For the example here, we imagine that we want to merge the product and description entity into a single entity called product. And we want to create a new entity called credit card containing the credit card information from the entity user. So once you execute the evolution script on these queries, you will get this result. So you will have each modified queries with a command and a flag. The flag could take the value unchanged, modified, running, or broken, depending on the outcome of the evolution process. And the commands will help the developer to know what went wrong and which operation impacted the queries. Here we can see that the first query was correctly modified and was impacted by the merge between product and description. And we see that we can select the description directly from the product entity as they were merged together. The modified flag tells the user that the modification was successful and the query worked correctly on the new version of the Polystore. There is a query with a running flag. The running flag tells the user to be careful because the query worked on the new Polystore but could have some side effect. Here, this query could now respond with multiple car number instead of only one. Then the last flag is the broken flag, which tells the user that the query couldn't have been adapted to the new target schema. We formalize all these transformation in this table. Here you have all the operation, the modification operation that could be applied on TyphonML schema, and you have the expected outcome of each transformation for each type of query: create, read, update, and delete. You can see here that the merge operator will set the running flag on a read query. Finally, the tool is implemented as an Eclipse plugin, and the code is available as an open source project developed with the Rascal MLP language, so don't hesitate to check it out. The limitation of our work is that it cannot yet handle the case where a query should be transformed in a script of multi-couple query, and our approach is not yet able to extract automatically the queries from the source code. To be noted, our approach will be evaluated by the Typhon project business partner in the following months. I have then several questions for you. Is it realistic and attractive for you to express queries at the conceptual level? And do you think that a unified query language could replace native one? Thank you for your attention and goodbye.